Okay, 3.3, antiderivatives and the formulas that go with them. So previously this semester, we learned all of these derivative rules, all these building blocks for taking derivatives. What we have on this section is antiderivative rules that go hand in hand with those derivative rules. So we have a constant multiple rule. So if we have k as some constant out in front, what we're allowed to do is bring that constant along and then take the antiderivative of what's next to it. We have a sum or difference rule saying that if we have two things added or subtracted, so you can think of these as separate terms, we can integrate each one individually. We have a power rule. So as opposed to the derivative rule for powers, where you bring the exponent down and reduce it by 1, we kind of reverse those orders. What we do is we increase the exponent by 1 and then divide by our new exponent. At the end here, we put a plus c to represent any constant can be added to this as part of the antiderivative. Now this works for any power except for n equals -1. We're going to talk about that in a second. One special case is when you just have a constant, its antiderivative is going to be when you put an x with it. And think about it, if we have these antiderivatives, we can always take the derivative to check our answer. With that, we're going to include a plus c as well. Antiderivative of e to the x is e to the x, just like the derivative of e to the x is e to the x. Antiderivative of any other number, constant a raised to the x power, is a to the x divided by natural log of a, and on every one of these we're going to include a plus c for a constant at the end. The kind of strange one is the natural log. Okay, natural log works out to be whenever you have 1 over x being integrated, which of course we could think of as x to the negative first power using our exponent rules. That turns out working out to be natural log of x, and technically the absolute value of x. So let's think about why you can't just increase the exponent using the power rule. What happens if we took x to the negative first and we increase the exponent by 1? Well, you get -1 plus 1, and then you divide by that new exponent. And I probably should put a plus c next to it, but let's just take a look at what this looks like. We get 1 over 0, x to the 0 power. Well, we run into a problem whenever we're trying to divide by the 0 power. Divide by 0. We say that dividing by 0 is not allowed, it's undefined. So it'll take practice in a few of these, but you're going to notice as you do them, if you try to use the power rule in this circumstance, you're going to be dividing by 0, and hopefully bells and whistles go off and you're like, I can't do that. That's not allowed. This is that special case where it's going to work out to be natural log. So I hope this helps out. Next, we're going to do a bunch of examples and practice, practice, practice.